Welcome to This Explainer. Okay, imagine for a second leaving the lights and air conditioning running in a house you moved out of like months ago. Why on earth would you keep paying for that, right? Well, in enterprise cloud environments, this exact absurdity happens literally every single day. We are Team GhostBusters, and we're here to solve this massive hidden financial drain.
Let's dive right in. We're building a project-aware autonomous FinOps remediation agent. Basically, it's a financial operations tool built specifically to hunt down ghost servers. You know, those development and staging resources that silently eat up your budget long after their actual business purpose is completely forgotten. And the financial scale here, it's absolutely staggering. Flexera estimates that 29% of infrastructure and platform cloud spend is pure waste. To put that into perspective, at a conservative $5 million in monthly cloud spend, that is $1.45 million bleeding out every single month. No way, right?
But here's the real kicker. Finding the cost isn't even the hardest part. 40% of FinOps practitioners say getting engineers to actually take action is their biggest headache. Finance spots the bill, sure, but engineers hold the context. And frankly, nobody wants to break some hidden dependency.
So this leads to a massive missed opportunity. Simple, low-risk actions, like just scheduling instances to turn off outside of business hours, can yield up to 70% savings according to AWS. Yet, because fixing it is so fragmented, all this money is just left on the table. Now, existing tools on the market, they're great at detecting idle resources and recommending cuts, but a dashboard telling you, hey, this server is underutilized, doesn't tell you why it was built, if the project is still active, or who even owns it. The massive unresolved gap is establishing that business purpose before you ever try to touch the code. So here's our solution. GhostBusters is built to determine whether non-production infrastructure still has a valid business purpose. We aren't just glancing at basic server metrics. We've actually designed an intelligence layer to safely propose real engineering changes. We do this by dynamically combining financial, technical, and project evidence. So instead of blindly killing a server and crossing our fingers, our agent actually reasons through all that context to generate a validated remediation pull request. And most importantly, this pull request is generated only after authorized human approval. We purposefully keep the human in the loop to ensure absolute safety and trust. Section 1. Our agentic workflow. Deconstructing the architecture. Our autonomous agent operates in 4 really deliberate stages. It kicks off when a webhook triggers a deterministic Terraform plan. Think of that as a blueprint of infrastructure changes. From there, it flows right into our LangGraph investigator, moves on to the optimizer, and finally passes through the verifier. Let's break down that investigator phase. First up, it pulls live or mocked AWS pricing data. The agent absolutely needs to understand the exact financial impact of whatever resource it's looking at. But it doesn't stop there. It dynamically cross-references that cost with CloudWatch utilization metrics. We refuse to rely on just a single weak signal like low CPU usage to make a major decision. Next, it pulls project milestones directly from Jira and commit history from Git. This is huge. If Jira says a project is totally complete, but Git shows developers are actively committing code, our agent is smart enough to spot that contradiction. Finally, the investigator confirms code owners and maps out the dependencies. The agent has to know exactly what might break if this specific piece of infrastructure is altered. Once all that evidence is gathered, our optimizer kicks in. It compares several safe alternatives. Maybe we downsize the resource, add an off-hours schedule, or make it ephemeral. And importantly, if the evidence conflicts at all, the agent is programmed to just safely abstain from acting. Then comes the verifier. We test the proposed action against hard organizational rules using the Open Policy Agent. Literally only a recommendation that is both highly valuable and totally safe will proceed past this gate. Section 2. Human control and safety. Autonomy where it helps, control where it matters. Before touching any repository code whatsoever, the agent sends a rich, detailed evidence card directly to a reviewer in Slack. A human can approve the PR generation, modify it, request more data, or just reject it entirely. Crucially, there is zero direct cloud execution. We never bypass your existing branch protections. Section 3. Phase 2 Prototype Execution. Proving feasibility. We are utilizing a highly focused, robust tech stack, integrating AWS, Terraform, GitHub webhooks, and Postgres. Our upcoming demo is going to prove 3 critical outcomes: successfully generating a high-confidence remediation PR, safely abstaining when evidence is murky, and intelligently recovering if an API tool suddenly fails. And this architecture allows enterprises to adopt our tool super rapidly. GhostBusters acts as a thin, low-friction connector layer. It sits gracefully right on top of your existing tech, meaning your current repositories and CI/CD pipelines remain completely untouched and unchanged.
So why are we pitching this for the NeuroX 1.0 competition? Well, we discovered this challenge via Hackathon Hub, and what really drew us in was the mandate to move way beyond basic chatbots. We've built an agent that genuinely reasons, uses complex tools, handles failure gracefully, and drives massive B2B financial outcomes. To wrap things up, GhostBusters doesn't just passively report cloud waste on some dashboard. Our agent investigates the reason behind it, proves the safest action, and hands your engineers the exact pull request they need to stop the leak. So, the only question left for you is, are you ready to approve Phase 2 and help us find the ghosts?